So, I guess it works. Yeah. Good afternoon, ladies and gentlemen. Let me start the next session. My name is Ilya Kosmodemiansky, and I'm working for DataGrid, small PostgreSQL consultancy. And we will talk today about upgrading Postgres. So, I do not intend to just read you the documentation for PG upgrade or utilities like that, because most likely you can do that on your own. I just want to give some general descriptions, some guide how to use existing options to upgrade your PostgreSQL installation, and give some details which are quite useful and which are better not to be forgotten. So in Postgres, we generally have a very good reference documentation. So it's like manual, this option means this and that, but we are lacking of guides. Like Oracle, for example, has 2 DBAs, which basically you can read and figure out how to do things. So I try to give it to you right now in some way. So why this talk? Theoretically, upgrading your PostgreSQL installation, it's quite easy, it's not a rocket science. But I suspect that you come up to this conference and to this talk in particular, not because I'm so awesome, but because you have some problems with PostgreSQL upgrades or some questions how to do that better. And I would say that in general, upgrade is not a big deal. There are lots of small details which can screw the things up. And besides of that, you know, upgrade is a very tricky procedure because you can definitely ruin your data. You can end up with significant downtime. And most likely, if you upgrade successfully, that means you spend lots of time to prepare, and then you perform the upgrade successfully. So because of all those details, you need to pay attention to the preparation phase. And I intend to give you some clues how to do that better. Because upgrades are so tricky in many details, especially in Postgres, DBAs generally do not like to upgrade their PostgreSQL installation. I assume many of you consider themselves as DBA, yes, because why you're attending this talk otherwise? Who likes to upgrade your Postgres? So, well, I like, because we are providing consultancy per our base. So in some sense, I'm pretty much happy that Postgres has so awkward upgrade procedures. But I try to simplify it for you. As a first step, I would say that keeping attached to old versions is a bad idea. And actually, it's the first step to screw things up if you upgrade your PostgreSQL rare. Because you need to upgrade because of bug fixes, because of enormous improvements in performance, because of security fixes and things like that. And it's just like if you're, for example, a medicine doctor, if you perform some manipulation oftenly, you would be probably very skilled in this operation. So if you try to upgrade your Postgres once upon 10 years, most likely that will be a pain for you. So try to make this procedure familiar to you, and that's why you need to upgrade often. And besides of that, if you run version 7 or even version 8 in 2017, you will make your database support guys very happy, because they can spend a lot of time and charge a lot if you need an upgrade from an old version. So what's about version number now in Postgres? Up to 9.6, we have 3 numbers. First we consider as major numbers, and that's a bit ridiculous. Why we have two major numbers? And because nobody can figure out what's the meaning of having two major numbers. Since version 10, PostgreSQL developers switched to two numbers. One of them is major and another one is minor. And for example, in 2017 would be 10.2, and the next release will be 10.3, and then in next year it should be 11.1, and so on and so on. Why I'm talking about that? Because depending on which version you upgrade to and from, there are different types of upgrades. The minor upgrade, which is a relatively simple thing, then you upgrade only a minor version, and a major, then you upgrade a major version, and actually the difference between those two versions are in general that lots of functionality can be added to the next major version, and storage format, even storage format can be changed. So you need to perform special procedure because you just cannot stop and start with new binaries on the same data files. Besides of that, there are major upgrades with some special requirements, which is quite common thing. Then you, for example, do not have enough disk space to perform dump restore or things like that, or you have very heavy workload, or you need to upgrade, skipping some major releases, and you need to upgrade from very old, outdated PostgreSQL version. So basically, we will talk about general approaches to those types of upgrades. Before any upgrade, read carefully all version-specific release notes. There is special appendix E in, I believe, E in PostgreSQL documentation, which describes what was changed between upgrades. For minor upgrades, that it's not so critical, but for major upgrades, it actually can be different parameters. They can be renamed in PostgreSQL conf, like in 9.5, we now have minimum wall size and maximum wall size instead of segments like in previous versions. And then you perform an upgrade, you need to change all those parameters appropriately. So better read these release notes for all versions, especially if you're skipping some release, just to be sure that you are aware of all changes which are exposed to you as end user. Play with chosen upgrade method in your test environment and communicate to your developers team. Because, you know, developers can be creative. And there can be lots of tricky things in your schema. It can be lots of temporary tables, lots of databases, and some application-specific behavior. So then you plan an upgrade, consider to talk to developers when, how you can do that, and most likely try to do that before on your stage environment together with your application team. And just in case, even if you're performing minor upgrades, which we consider to be much more safer than major upgrades, make a backup and check this backup using test recovery, because it's usually better to be on a safe side. So make a backup before you're experimenting with your production, because something can go wrong. Minor upgrades, as I said, are quite easy. You simply install new binaries and start a database over the old data directory. Because there are no major features between minor versions, that's the difference between those two versions, most likely you do not need to change anything. So you just can use the same data files. But actually keep an eye on all the packages you are using with your Postgres, and just check this list if you need upgrade this package or that package, because even with minor upgrades, some things can work wrongly. For example, it's not a big deal if PostgreSQL client would say that I'm of a previous version. It still will work with a newer version, but it's better to keep things sorted and have all of the packages upgraded properly. Major upgrades are much more complicated because some features can change internal data representation. They definitely change system tables and lots of internal things in Postgres. So you basically cannot just start up on the old data files, and you need to perform special procedure of upgrading that. You need to pre-install all the PostgreSQL related packages, check if you really not forget any of them. I will talk about that on the next slide. As I said, with any upgrade, read carefully all release notes, and actually I suggest to read not only release notes, but the paragraph in the documentation which corresponds to upgrading process for all releases you're trying to upgrade, because there can be some release-specific recommendations how to perform upgrade. Then you can try to check if all your packages are working. So just try to install new cluster, then you can remove it. But it's better to realize that everything goes okay and not wrong, and this wrong in the middle of upgrade can screw your database up. Know your PostgreSQL installation, because if you are aware of amount of tables, for example, or temporary tables or sequences or some specific extensions in your exact installation, that will help you to plan upgrade carefully, because all of these things, they can influence which sort of preliminary things you need to do, what window you need to perform an upgrade, how long will be downtime, and things like that. Then you can choose the method how to perform major upgrade. There are several of them, and we'll stop on each and discuss it in more details. Again, communicate with your developers team, because they definitely need to not migrate their schema to new version in the same time you upgrade in the Postgres. So everything should be actually quite good planned. And do a backup. I just repeat it again because it's very important. While you are checking the packages you are using with Postgres, if you have Debian or Ubuntu, you can use dpkg packet and try to figure out which packages you are using and which packages you need to install from a new version. Take in mind that not every PostgreSQL package can be found if you're just listening the Postgres, because some of them are using different names, and for example, PG can be much useful. So carefully inspect which packages you are using. And not necessarily you need to upgrade all the packages, because when you upgrade PostgreSQL, most likely your PG bouncer will work with previous version of Postgres and with new version as well, because PG bouncer release cycle is not so frequent like Postgres one. So basically you need to figure out if you need to upgrade this one or do not need to do that. But you definitely need to upgrade contrips, client, maybe developer package, and all related to the PostgreSQL server. So basically we have three major methods of upgrading Postgres. old school or naive approach, or whatever you can call that, PGDump and PGRestore. You have so-called in-place upgrade, PG upgrade, and you can use some replication-based method to upgrade Postgres. So what's the difference, and in which situation you can use one or another method? Theoretically, you can perform a major upgrade using PGDump. It's the oldest way, and it actually works pretty much fine, because PGDump is good tested piece of software. Okay, there are some issues. Recently, there were some bugs in PGDump, but still, if we compare that to any replication method suitable for upgrade or to PG upgrade, I would say that maybe PGDump is the most reliable piece of software. Actually, the main drawback of PGDump is that it's too difficult to make an upgrade without downtime, especially if you have a large database, heavy loaded with lots of concurrency and things like that. I would say that this degree of how large your database can be to use PGDump is pretty teeny. So if you have several hundreds gigabytes, from point of view of upgrading your database with PGDump, it is already big data. It takes a significant amount of time, and you need to consider that sort of downtime. PGDump definitely requires additional disk space. So basically you need dump and then restore, or you can do that in very risky manner. You can dump, restore and destroy the previous data directory, which is definitely not the thing I would advise you to do. The good thing is it works with pretty much every version of PostgreSQL since version 7. And it is pretty much very efficient now. So you can use PGDump in custom format, -fc, and that's actually one of the options you can use, because if you're just using plain text version, there can be issues with large objects if you use them somehow and just don't do that. At least you need to use custom format. You can compress that, so if you decided to upgrade database on a different server, which can be a good idea in some cases, you can transfer that through the network much more efficiently. But actually, if you have not enough CPU, compression can be a bad idea, and you probably should use -z0 to not compress the dump. Sometimes you can minimize your downtime using parallel option with PGDump, like -fd, which means directory, and -g or -jobs to parallel PGDump, and then you parallel PGRestore respectively. You need to use this directory format to do that, because in our case you cannot dump your data in several processes. But take in mind that this method consumes CPU, and you cannot simultaneously restore the data. You need to perform wall dump, and then you only can start with restoration. So basically, this method in terms of downtime also have lots of limitations. But basically, if your workload and the size of your data allows you to upgrade using PGDumps, that's a good thing for you. You can just rely on very easy and very bulletproof way of upgrading Postgres. So if you can, do that. But if you have another prerequisites, this method may be not good for you. how it looks, how the procedure of upgrading using PGDump looks like. You just install the new binaries, you initialize a new cluster. Don't forget to initialize that in a proper locale, especially if you're using some specific national things like Chinese, Japanese, Russian, German, French, because if you initialize a new cluster in locale C, all the text compression things and full text search and indexes would not work correctly with these national characters. So do not forget about that. You need to change config files appropriately. I already told that from major version to major version, it can be changes like checkpoint segments to max wall size, min wall size. Consider to look into documentation and figure out the list of those changes and change them. Then you restore the dump and you can try to figure out that everything is okay, try to use checksum, but it's really difficult in comparison to PG-based backup to figure out that everything definitely is okay. But in this case, you just trust that if the PGDump was restored completely, that everything is okay. And then you switch your application to new cluster and probably can destroy the old one. Sometimes it's a good idea to use PGDump from the new server to which you are upgrading, because backwards compatibility is declared, and theoretically the newer PGDump can work with older versions. And it's a good idea because you can benefit from these parallel things which are relatively new even on old database server versions. But you need to be careful about that because, for example, if you're running version of Postgres before 9.2, you still can use parallel things, but you definitely need to disable all data modification inside your database, just, I don't know, using PG bouncer and pausing that, or just kicking all the connections from your database, because otherwise you will have a problem with restoring all this dump. Another method is a PG upgrade. And this is a small outline what I will discuss about PG upgrade in this talk. First of all, I will discuss how it works, not with much details, but still. And then we discuss a procedure in a simple case, then we upgrade in a standalone server. We'll discuss how to minimize downtime while upgrading using PG upgrade. And we'll discuss how to upgrade the cluster with hot standby. And then I cover some details because this is much more important because it's difficult to find out in documentation. So basically how it works. We have two clusters of PostgreSQL, the new one and an old one. The new one is empty. It contains no user data of any kind. And the old one contains user data, and besides that, it contains some internal data, PG catalog, PG class, PGClog, which is renamed now, but I use this one because version 10, where it's renamed, is not in production now. And we have PG control data, and the idea is that we actually can change these internal data because we have new features and it was changed with new version. And just take the user data and put it to the new server, and we can run with new system tables on the old user data. But we need to perform some conversions to do that. And the idea how PG upgrade do that, besides of some sanity checks and some things like to check if locale is okay and things like that, it just freezes the new cluster that allows to remove the PGClog, the current state of transactions on the new master, and take the PGC log from the old cluster and to move it to the new one. And besides of that, PGUpgrade moves control data, and that allows to have the same visibility map, the same seed on the new cluster. After that, it's possible to dump and restore all the system tables with all necessary configuration things. And after that, user data can be moved or hard linked to the new cluster. And after that, you can start and basically you have a new database cluster. So let's outline how it works. So it decouples PGC log and moves user data, and that's it. I will give you some reading list on that in the end of the talk. And there is a good talk by Bruce about how it works internally with much more details on that. But for us, the procedure is a bit more important. So how you proceed with upgrading? You create an empty database, that one we use to migrate to. You stop the database with old PostgreSQL version. Then you start upgrade with PGUpgrade command. Then you start the database with a new version if everyone was successful. Then you start to collect the statistic because PGUpgrade do not move the statistics from the old cluster. And at some point, I will discuss that on the next slides, you can actually open your database for your application, and that's it. But as I already mentioned, the problem is not the general guideline how to run PGUpgrade. The problem is lots of small details. Before we go to the details, I will discuss how to minimize downtime. My favorite way to minimize downtime while still using PGUpgrade is to use PGBouncer. PGBouncer allows you to pause it, and it has a client queue written with lib event, and then you actually pause the PGBouncer. All the new connections will wait in this queue. And if you are lucky and smart enough, you can restart PGBouncer while your clients are waiting for the connection. And if everything goes okay, that means that you transparently upgrade your PostgreSQL and no connection drops, just small growth of latency. To do that in a smart way, you need to issue checkpoint before you start the whole procedure, because then you start trying to stop PostgreSQL, especially the PostgreSQL which is optimized for high volume of write workload. You need to issue checkpoints, because otherwise then you try to stop the cluster, then PGUpgrade do that for you. You will wait for a long time on a heavy workload, and in that case, this trick with pausing PGBouncer would not work. So issue checkpoint and then proceed. And another way, which is actually a very good thing about PGUpgrade, you can use -k or --link to not move the user data, but to hard link it to the new cluster. You need to be careful, because if you relink your user data unsuccessfully, basically that's it. The only thing you can do is just to fail over to the replica, to hot standby, because there is no way to start safely the old cluster which was corrupted with this type of relinking. So if you're copying, that's basically the same thing like you issue in PGDump, because the copying can be very long and it's difficult to keep with short downtime. But if you're relinking, that can be a good idea, but you need to do that carefully. If you're upgrading hot standby replica, The procedure is basically the same on master. So you upgrade master as I described with standalone server using PGUpgrade. But you try to keep the replica intact, because if something goes wrong on your master, you can just fail over to replica. And if everything is successful, you just reinstantiate replica, and basically you create the new replica. So there are some details about that I'll discuss a bit later. But the procedure is just the same. You pause PGBouncer, quickly do all the stuff, and then you resume PGBouncer. But then details. PGUpgrade do not transfer optimizer statistics. And then it successfully finishes. It suggests you to run this script, analyze new cluster. Basically, it runs analyze in stage, vacuumdb -all -analyze in stage. So it performs all the analyzing for your optimizer. In some cases, it's better idea to do vacuumdb -analyze only. It will very basically collect your statistics and do not taking care on the custom statistics for columns, but it can be much faster. Since 9.5, you can run not this script analyze new cluster shell, but you can do that manually in many processes. And that can be a good idea if you have lots of objects in your schema, custom statistics, and things like that. But actually, in most cases, we just run vacuumdb manually with analyze in stages. And then we collect the medium optimizer statistics, so-called 10 targets. We we open the database for our application. Because it's a better idea to open your database to application, resume bouncer, then you have no statistics. All the queries will be quite bad, and you cannot predict how bad they would be. So it's a good idea to start that. But if you do that simultaneously, you can run into some log issues with collection of statistics and your queries. So it's a good idea to start statistic collection, wait a bit to the second stage of vacuumdb, and then run your queries from your application. Another good detail is that documentation suggests to use rsync to reinstantiate standby while you're upgrading. Sometimes it's a good idea because you can use hard links, you can save a lot of network traffic in comparison to PG-based backup. But actually that provides you with a lot of opportunities to shoot your leg, because you certainly need to know what you're doing. Because if you have table spaces, you need to modify this script. If you have walls outside the data directory, you need to run a sync for that walls. And it's the best way to shoot you in your foot than you write custom backup rsync scripts. So maybe a PG-based backup is not so good about performance, but it's bulletproof and it just works. So I suggest to use PG-based backup in that case. Debian and Ubuntu have their own way, and they have this written in Perl wrappers like pgctl cluster to manipulate Postgres in Debian way. PGUpgrade cluster is the option to upgrade your Postgres installation in Debian way. Then you just hit the bottom and suppose that everything will be good. So this command on the slide will upgrade to version 9.5 from version 9.3. This is the cluster name. -m upgrade says that method would be PGUpgrade instead of default dump, and -k suppose it would be relinked. But actually, I strongly do not recommend to use that because there are lots of issues. You cannot minimize the downtime using PGBouncer because it tries to do everything for you. Sometimes there are bugs in those scripts. And besides of that, those scripts are doing things for you, like if you have checkpoint segments like this, they changed that option to max wall size and min wall size, and you cannot guarantee that they do that correctly, and after that you definitely need to recheck those things. So basically I suggest to do that still manually. So if you like Debian way, just use PGCTL cluster, but I do not advise to use PG upgrade cluster. That can be unsafe. Extensions can be a real issue with major upgrades, because PG upgrades keep the old versions of extensions, and the extension system is not the best design probably in many ways. So you need to check every extension, every version, and it's safe to issue alter extension, extension name, update, and that brings nothing bad, but most likely your extensions would be upgraded correctly. Of course, there are corner cases then, for example, there are dependencies between extensions, and basically inside extension you can do everything. So if you're using some extensions, just try to figure out how to upgrade that and exercise that before. For example, if you're using PostGIS, you need to upgrade PostGIS first to the newer version, and after that you can proceed with upgrading your Postgres. Another option, which is more modern but at the same time very old, you can use replication to upgrade your Postgres. So streaming replication does not work with different versions. So basically the most robust and the most convenient way to replicate data in Postgres do not allow you to upgrade. But some replication methods do that, like logical replication newly introduced in Postgres, and which is supposed to be the native mechanism to replicate Postgres. It should be included in version 10. Old ugly Sloaney or old beautiful Sloaney, I don't know. I think Sloaney is a very useful mechanism still, so I think they are beautiful, but many people do not agree with me. For example, Magnus definitely don't like Sloaney. Or OneDist, and yeah, OneDist, I don't like OneDist, but some people do like it. The procedure is simple. You just set up the new database cluster of newer version. You set up replication for a whole database, which can be tricky, for example, for trigger-based replication of OneDist, because those solutions designed to make actually partial replication. And then you perform failover. The benefit is that you simultaneously have both versions, you synchronize in the data, and it's supposed to be quite flawless. So basically you can try anytime, you can go back, but actually if you have complicated data schema, that can be tricky because this replication is not very flawless. There can be issues with that. So logical replication, it's a new and very promising method. Most likely it's much easier to use that in comparison to Sloaney or Londice or whatever, your lovely self-made trigger-based replication. And that allows you to upgrade from version 9.4 more or less to any modern version of PostgreSQL. But it can be actually tricky. You can check the documentation carefully, and it's not very easy documentation. So if you have a complex schema, you may need some wrapper which actually set up the logical replication for whole database for you, like PGRepup, and it's on your own risk to use that. If you have lots of tables, it can be really tricky. You can check that what actually your replication working with, because by default it can replicate inserts but not replicate updates, and you either switch it on or you ask your developers not to issue any write queries. After that, you, for example, can run into the problems that you need to reset sequences. So scrutinize carefully the documentation for PG logical, because there are lots of issues you can run into while trying to upgrade that. But I repeat again, it's a very promising method because no downtime, you can do that theoretically very easy, and most likely logical replication would improve in PostgreSQL in future. So another version is Slowney. It's old and bulletproof, and for some persons it's ugly. Basically, it's the same thing. You just set up the replica and failover. The very good thing from my point of view is you can use Slowney with very old versions of Postgres. And the failover can be really fast. Even if we compare that to PG upgrade, I would say that Slowney, if you know what you're doing, can be managed with zero downtime. You just pause the PG bouncer and switch over. Drawbacks is it's trigger-based, so basically, besides of extra disk space for second copy, you can double your write workload for your database. That's bad. LongDist, just a disclaimer, I do not like LongDist because it's too over-engineered from my point of view, but it's only my opinion. But it has some drawbacks like Slowney without that bulletproof robustness. It has lots of bugs, especially if we're talking about SkyTools 3. And these tools was designed for different purpose to make some partial replication. So to replicate whole complex database schema for upgrade, that's probably not a good idea. But some people prefer LongDist to Slowney. As a conclusion, I would say that all of those methods are not perfect. And if we compare, we can see that we can risk and minimize downtime, like using PG upgrade with hard links. The risk is very high, but actually we have low disk usage, we have low downtime, but it's complex, so we need to prepare well, but it's complex with any type of upgrade. Even if I say that dump restore is easy, you saw that you need to figure out the proper dump format and things like that, so it's not very easy actually. And actually I mentioned that Slowney is medium complexity. For me, it's medium complexity because when I started to work with Postgres, that was the single workable solution to replicate the data, so I knew how to cook Slowney. But for many people who just take a first look on that, that's crazy thing. So it's arguable that it's so easy to do that. So basically, we have this compression chart, and we see that it can be risky but effective, or ineffective with less risk. It's your decision to choose one or another method. And as a last slide, I actually suggest you some reading list, some useful links on the topic. There is the good presentation made by Bruce about internals of PG upgrade. I totally recommend that. The second quadrant blog post about update. If you just separate yourself from all marketing things about beautiful logical replication, it contains lots of good things, so I definitely can recommend it. There is a good blog post about the differences between different options of VacuumDB in terms of restoring the statistics after upgrade. So if you're interested in this topic, read this article. And this is good blog post by Depesh. Then he tries to make a logical replication. So if you're looking for just example how to do that and try that on your stage environment, it's a good reading to figure out how to do that. So now we have, I believe, 6 or 5 minutes for questions. And anyway, thank you for your attention. And if you have questions, you can ask them now or later send me an email. Questions?
I've been having a problem with materialized view.
So the question was, I repeat that for the record, problems with materialized view and PG upgrade. I would say that materialized view are far away from the state they are usable. Basically, I suggest to replicate them, replicate the data using some sort of logical replication like Saloni or logical replication itself, and then recreate materialized view. So that can be one of the solutions. It depends on the complexity of your materialized view and other things. More questions? So if we have no questions, then thank you and enjoy the conference.